Okay, SEC sample paper 2, question 2. It's to do with expected values and probability. So you have a biased die is used in a game. So a biased die is basically a dice which is not equally likely to land on each of the numbers. It favors one number more than another. So it says the probability of getting 6 different numbers on the die are shown in the table below. So the probability of getting 1 was 0.25. So 25% of the time you're going to get a 1. 25% of the time you're going to get a 2. 15% you're going to get a 3. 15% of 4. 10% of 5 and 10% of 6. So it says find the expected value of the random variable x, where x is the number thrown. Right? So in terms of expected values, normally what you do is you go probability by the money won. Right? If you're doing money, like in a competition or a fun fair, we haven't got money here, we're going looking for numbers. So you would go probability times number, probability times number, probability times number, and repeat it for all of the 6 numbers. Okay, work out the probability times the number each time. So that's 0.25, that's 0.5, 0.45, 0.6, 0.5, and 0.6. And then what you do is you add them all up. So you add them all, so you get 0.25 plus 0.5 plus 0.45, 0.6, 0.5, and 0.6. And you add them all up and you get 2.9. So the expected value you would get on that dice is a 2.9. Part B, it says there is a game at a fun fair. It costs €3 to play the game. The player rolls the dice once and wins back the number of euros shown on the dice. The sentence below describes the difference between using the above biased die and a fair dice when playing the game, by doing the calculations required to complete the sentence. So if you play the game many times with a fair dice, you will win an average of some amount per game. But if you play it with the biased dice, you lose an average of something. So for the biased dice, the one we have worked out above, for the biased dice, we worked out the expected value was 2.9. If you are paying €3 to play the game, €3 take away 2.9 will mean that you're expected to lose 10 cents. So you would add 10 cents in there. If you're playing with a fair die, the fair die would mean your probability of getting any of the sides would be the same. So it'd be a 6. So you'd have a 1/6 times 1, 1/6 times 2, 1/6 times 3, 1/6 times 4, 1/6 times 5, and 1/6 times 6. So you'd work out those probabilities. So 1/6 times 6 would be equal to just, if we keep them as fractions, so 1/6, that will be 2/6, that's 3/6, 4/6, 5/6, and 6/6, which would be 1, and then you add them all up. So if we add 6 and 5 and 4 and 3 and 2 and 1, you would get 21/6. So 21 divided by 6 as a decimal is the same as 3.5. So that will be the same as 3.50. So if we're paying €3 to play the game and we are likely to win 3.50, you will win an average of 50 cents. Okay.